an hour, starting half an hour as per the schedule from half an hour late. 30 minutes we give time for them. They were busy in study. Right. So, dear students, now this is the second class in the line with the pressurized irrigation. You remember in the previous class I have taken class on sprinkler irrigation system, in which I discussed the components of sprinkler irrigation system. I also, explained you about the what are the various, besides the component, what are the advantages when we can use sprinkler irrigation system, and also I discussed about the different parameters to evaluate, and gave you an example, numerical means problem, the data which were collected from the experimental setup which I shared you, and I asked you to evaluate. Besides my own lecture, I also showed you the video clip which was giving you the complete detail how the measurements are being taken and how a sprinkler irrigation system it operates. Now in today's class it falls in the same family of pressurized irrigation system, and water is emitting out of the outlets provided in the pipeline. The difference here with the sprinkler overhead sprinkler system or pressurized the sprinkler system which I discussed, it operates at low pressure. The pressure requirement is lesser, and this system is permanently installed in the field or for a particular season. If it is a seasonal crop like vegetables, then it will be installed for that particular period only, and then it can be removed after the season. But in case of sprinkler irrigation system, it is a in majority of time because our farmers cannot afford, so it is a portable system there in a sprinkler system, but here in this case it is a permanently installed. Then another difference with the sprinkler irrigation system, this system is operates at low pressure, and then the water is given exactly at the desired where irrigation is to be given, means at exact appropriate location is there. When in case of sprinkler irrigation system, it sprinkles water in all the places. So in case of drip irrigation system, water is being given exactly at the root zone of the plant. Now root zone, when I say, it is something like the water is being given or the nutrients are being supplied exactly at the mouth of the plant. Mouth of the plant is root, because plant takes its water as well as its food through the root system. So roots are means it's like a conduit. So what it is happen in the plant, it extracts the water and nutrient through roots, and then it is distributing to all the parts of the plant. Means practically it will come from the root, it will come to the stem, then it goes to branches, from branches and then it will go to the leaves. So every points are covered, and then when we are giving water, so water is coming out from the leaves, that is stomata of the leaf. So it behaves like it is a pump. What happened when say energy, it is being plant gets energy through the solar systems, sunlight. So sun is providing energy plant to activate, and the pumping is being done with the help of the root system. So it is transported from the root to the leaves of the plant, and finally it water oozes out or it is discharged to the atmosphere. So this is the system it works. Now in case of micro irrigation system, it is the same as that. It can be laid on a plain land, or it can be laid on a hilly terrain. It can be also laid in variety of soil conditions. Not necessarily it should be only sandy loam soil or clay loam soil. Accordingly, only that the discharge is manipulated. So in case of sprinkler irrigation system or drip irrigation system, the rate of application or discharge which is coming out of the emission device, it is manipulated in such a way that whatever amount of water which is being released through the emission device or through sprinkler irrigation system, it is matching with the infiltration capacity of the soil. It's a very important thing. It matches with the infiltration capacity of the soil. So this is another thing. Now I was telling you the difference. Difference part is here that in case of a sprinkler system, you are giving sprinkling water like which resembles rainfall, but here water is being given drop by drop to the individual plant or close growing plant. Suppose it is a vegetable crop where 4 plants. So one dripper, it is meeting the requirement of 4 plants, 6 plants, or 2 plants. That depends. So this is there. And then another part is the irrigation interval. So water is given in a very short interval. In case of drip irrigation system, means it's a low quantity of water supply, number one, and also the irrigation interval, it can be a every day or alternate days or maximum 2 days interval. This is important. So means the depletion of moisture content from the soil to the root system means it is not allowed like sprinkler irrigation system or surface irrigation system. This is a very important thing here. We are giving water at a shorter interval. So in case of drip irrigation system, water is supplied at a slow rate, mean discharge rate is lesser, number one, and then irrigation interval, it could be daily, alternate days, or maximum 2 days interval. Of course, then means we are manipulating or we are maintaining the moisture content every time up to the field capacity. Now let us try to learn, because today I will be giving you theory information about the drip components, and then I will also discuss about these drip filters, and then how to evaluate these drip system drip emitters. So the different parameters I will be discussing you, and also in the laboratory condition, how the data are being collected, that will be explained to you. And so in the lab condition and also through in the field. So my PhD student, those who are there, those who are assisting you in this particular live class, I have given them video clips. So after the class, when theory part is done, and I will share you the data, then today's class as well as tomorrow's class, after this data which is being given, you need to work out soon after the class and submit to Professor Mishra, and then also we will have a formal that what you have learned in these two classes, sprinkler irrigation system as well as drip irrigation system, after the class. So after you see the, our video clips, then we will have this discussion. Okay, so let me start the sharing the this particular class material. Okay. Hope it's visible. Whether you are able to see?
Yes, sir.
Okay. Just a minute. So, you know, uh, for any system, whether it is a sprinkler system or drip system, there must be water supply system, means where is the source of water, and this source of water should be adequate. When we are planning system, means we should have a adequate amount of water available so that the all the plants from that source irrigation can be given. Suppose it is a perennial crop, like if you have a permanent orchard, let it be mango, it can be guava, it can be any fruit crops, which is a permanent kind of a thing. So if the crop will need all throughout year water, means annual. Now that whether my source of water, whatever it is there, whether it has adequate volume of water available, this is must. Now this source of water could be flowing water, maybe it is a river, or it can be a a pond, or it can be groundwater, like what you see here, a well. So well, it is it is a source, means here water is there, it is a groundwater, and then we have means we have a made a well which is a circular in shape. So you can say it is a vertical cylinder. Now in the vertical cylinder, water is coming through a, means a groundwater source. Maybe it is a unconfined or confined aquifer. The water is being coming, water is coming to this well through a confined or unconfined aquifer, and then it is being pumped. So source of water is groundwater, and there is a well. Now this, from the well, water is being taken with the help of a pump. Now this pump is a coupled with a electric motor. It is same as, if you remember in case of sprinkler irrigation system, I discussed, so same thing here. Only thing that since it is a drip irrigation system, I told you the water is being given daily or alternate days or in 2 days interval. So volume of water needed is small, and as well as the total rate of discharge is also small. So relatively the pump size or horsepower of pump is lesser than the sprinkler irrigation system. Why I am every time repeating sprinkler system, so that you are able to recollect that whatever I covered in the previous class. So there is a pump, and this pump is in here, it is being driven by an electric motor. It could be also, this pump can be also driven with the help of a diesel engine. So engine will give prime, that is a prime mover that will operate the pump, and then water is being taken. Now this water is being taken. So this side, what you see, this is a suction end of the pump. This is the suction side of the pump, and this side is a delivery side of the pump. So this is a delivery end, this is suction end. And then when water is being taken, it may be, you may find that size of the pump which has been designed, maybe it will be needed to irrigate larger area. But for the time being, suppose in a particular point of a time, you need only that smaller quantity of water to be discharged, or it should be taken out, or it is a requirement. So what happened? The pump is drawing larger amount of water, but you don't need that much amount of water. So what you are doing? Part of the water is diverted back to the source of water. So diverted back to the source of water, only the partial amount of water is allowed to flow. So this is sometime it is needed, that is a bypass valve or bypass assembly system. It is there. So part of the water, because pump has taken out more discharge, so it is not needed that much amount of discharge in the field. So you are just giving partial amount of water. Then it goes to the NRV. What is NRV? This is a non-return valve. NRV is a non-return valve. What is this non-return valve? The non-return valve means water can go this side, but it cannot come back this side. So only one direction flow. Okay, it is something like similar to the way you are giving, in case of your cycle pump. So in cycle, when you are pumping air inside the tube, so you can, what you are doing, you are putting air, so it goes one way, but it is not reverting back, because there is a one wall kind of a system available. Similar kind of a thing. This is a one direction or single direction wall. It is there. Now it comes to the filter. So this filter is a sand filter, or we call it as a hydrocyclone filter. Hydrocyclone filter, as it the shape says, that is a conical shape. So what happened? The water comes, and because of this conical shape, so water, it is, there is a centripetal force it causes because of the conical shape. So the water comes in a pressure, high pressure, it gets, so the large particles available. This is a, suppose pump is, it is a heavy duty pump. What happened? This is when it is water is being taken. So what the sand particles containing the water, what happened? It is being taken out with the help of a sand separator or hydrocyclone filter. So this part, here what you are seeing, there is a sand collection system, or where the larger particles get settled over here, and then the water will be taken. So this is the delivery end. This is the water collection basin or water collecting, this kind of a thing it is available. Then this is a outlet. Now this water will again go to the this place. Now here there is a nutrient injection system or fertigation unit, means water and nutrient both can be injected. Now there are various ways for the injecting system. One of the way is a Venturi injector. So there is a Venturi which has been installed, and then if we are interested to apply nutrient or any chemical which is soluble in water, that can be supplied along with the irrigation water. So water means water as well as chemical, it can be injected by using the here Venturi injector. Now there are various ways, one of the way that is your so this kind of a system, when it is being means fertilizer or chemical, when you can inject along with the irrigation water, we say it is a fertigation. It is also known as a chemigation. Chemigation means chemicals are injected. These chemicals are it should have a characteristic that it should be dissolved in the water. Sometime what happened, these chemicals, when it is applied and they react with the water, so it is likely, or it is not fully dissolved, and water is coming with the pressure. So those goes along with the irrigation water. So this needs to be further filtered. So in order to filter the this water, further filtration is needed. A sand filter or the gravel filter is provided here. So this is the inlet end of the filter, and this is the further outlet end of the filter. So water will it is applied, water is applied here, and then it goes to the bed of the which is put up here, and then it goes to the again, and then there is a screen filter. There is a screen filter. So water comes from this end, and then from the screen filter it. So you can see here, first filter was a sand separator or hydrocyclone filter. Then second filter is your sand filter, and this is the third is screen filter. Okay, it is not always desired to have all three types of filter. There can be only one filter, there can be two filters. So it will depend upon the quality of water. Quality of water, I mean to say, from the source, the water, what is the quality of water? Suppose you are taking water from a stream, or you are taking water from a pond where there is a lot of algae there, or it is a canal water. Now from the canal, when the water is flowing with the high flow rate, the velocity of flow is a very high, so it carries a lot of silt. It carries a lot of silt and smaller sand particles. So that is a causing problem in case of micro irrigation system, in case of drip irrigation system, because outlets of the drippers are very small. So it will depend that what is the quality of water. Accordingly, these different types of filters are used. Sometime drip irrigation system is used in case of when we are using foggers. Okay, when we are using foggers in case of a drip irrigation system, in case of your greenhouse system. So foggers, spitters, holes or outlets are very small. It operates at a high pressure. So those are, there is a possibility of getting those smaller openings likely to get clogged. So we are using these types of filter. You may have the disc filter there. So I'm going to show you some of those filters. Right now I will be showing you, then I will go to other parts. So what you are seeing here, that it is coming to, again there is a non-return wall. So water which is coming from this end, it should not go back and then go to the supply, source supply, because it may, what happened, it may contaminate the source of water. So better it is one side, flow only it is allowed. And then this pipeline is known as a main pipeline. This pipeline is known as a main pipeline. This main pipeline is, it is made up of PVC. It can be made up of high density polyethylene. It can be so, and then the diameter of the main pipeline will depend upon the amount of water which we are withdrawing by putting these walls, by putting number of sub main pipeline. Suppose you have a 5,000 number of plants, trees rather we say, or 10,000 number of trees, and we are interested to irrigate simultaneously all 10,000 number of plants, trees, mango orchard or guava orchard. So in that case, the main pipeline is likely to because it needs higher discharge to tackle, and all that means all 10,000 at a stretch you want to irrigate. Naturally, we will have larger size of the pipeline. Okay, now if you want to have that, no, I will not be irrigating at a time all the 10,000 number of trees, but I will be giving first 2,500 number of plants. Then next few hours you will be giving another 2,500. Then another, means you can have the total area divided into 4 blocks, and one block is, let us say, is like this. This is one block. Now this block, what you are doing it, you have got the ball wall. So this ball wall will be opened, and then all other, similar kind of three units will be there. So what you are doing, that no remaining other 3 units will be closed. This ball wall will be open only. This wall will be open only to supply water in the sub-main pipeline and all the laterals to operate. So then in that case, the discharge requirement for the main pipeline will be lesser. So that way, it is designed when we are considering the design case. Now this is a, so main sub-main pipeline is the branch of the main pipeline, or I can say sub-main pipeline receives water from the main pipeline. Now this sub-main pipeline is also made up of PVC. PVC is polyvinyl chloride. Okay, and HDPE, high density polyethylene. So these are, different types of polymers which are used for manufacturing of these pipes. The size of the pipeline and the thickness of the pipeline, the strength of the pipeline, it will depend upon the amount of water it is handling, or discharge it has to handle. So means your thickness of the pipeline, diameter of the pipeline, and then that is decided, and that is, you don't have to worry that part, because these pipelines now, these are all all these have got the Bureau of Indian Standard mark. Okay, so on this sub-main pipeline, laterals are attached. Laterals are smaller diameter pipeline. These are all smaller diameter pipeline. These smaller diameter pipeline could be 10 millimeter, 12 millimeter, 16 millimeter, or 20 millimeter in diameter. These are made up of LDPE, that is a low density polyethylene, or LLDPE, linear low density polyethylene. Now on these pipelines, drippers are attached. These are all drippers what you are seeing. These are all drippers. So these drippers are attached, and as I was telling you that each individual plants, trees, they can be irrigated, or a group of plants can be irrigated in case of your close growing crop. Okay, or suppose water requirement is very high, say it is a 10 years old mango orchard. So one dripper will not serve the purpose. You may need more than 2, 3, 4 drippers you may need. So that way, that is the way water is to be given to each individual drip emitters. Now what you are seeing here, this is a sub-main pipeline. Now in order to flush the water, sometime, if there are some dirt, some smaller particles, these are being deposited, then it can be removed. So there is a periodic flushing of the pipeline is needed. Similarly, in case of lateral pipeline, what in the lateral pipeline, what you are seeing, the drippers are attached, and in order to terminate the line, the end plugs are used. So you are seeing here end plugs, okay, like this, end stop, it is shown here, and this is the flushing valve. Now when we are interested to clean the line, so once in a week, it is required to be once in a week or 15 days, this flushing is to be done, so that the system remain clean. So these are the all components of a drip irrigation system model, which I have shown you. Now let us see some of the filters. So this is the system which is installed in a field, and you are seeing here this is a media filter. So there this media filter which I was showing you, this was a horizontal. This filter is laid as a horizontal. Now here it is a vertical filter. So water is coming from this and then it goes to this, and then finally after filtration the water is taken here. It is brought here and then it goes to this one. Then there is a I was telling you there is a fertigation unit. So there is a fertilizer tank. So water is coming here, it is dissolving the fertilizer, and then when the dilution takes place, and from this end the water is injected to the pipeline. So this is the head control unit part. Head control unit part means you have a pump kind pressure means the pump is there is a pump or overhead tank. Then you have got a media filter. Then you have got a fertilizer tank, and then there is a filter. Okay, there is a filter, and then there is a water meter. Then there are non-return valve, air release valve in order to release the entrapped air, and then there are from this what we are seeing here, the laterals are attached. So there is a main sub main pipeline or main pipeline which is attached, and from this main pipeline these are the smaller pipelines what you are seeing. These are all lateral pipeline. Okay, you can see here. Now what is the let us put it like very clear. What is the objective of the filter? To remove any suspended solids or particles from the irrigation water. This is a important thing. We are interested to remove all these things in order to prevent clogging of the filter. So clogging could be, what could be the reason for the clogging? It could be because of the deposition of the minerals particle available in the water. It could be due to chemical reaction of water with the when we are applying fertilizer along with the water, or sometimes so this precipitation takes place which is not desired. Then third part is biological, because in the water, if it is a stagnated water, it is likely algal growth takes place. So these are the basic causes of the clogging of the drip units or drippers, and we need to filter. So there could the filtration can be the very this is a very first process, that water which is coming, if it is water is being brought from the sand, from the river, from the canal, so it should be settled. The water should be allowed to store, so that the whatever the smaller particles which are available, suspended particles which are available, that can be settled in a settling basin. Then it will go to the centripeter. Just now I've told you centrifugal or hydrocyclone filter. Then it goes to the media filter or sand filter. Then it goes to the screen filter. So this is what you are seeing here. This is a sand filter. There are different types of filters. So this is one kind of when system is very large, and then what happened, the filter needs to be flushed also. So when you are seeing this is a multiple filters are there. There is one filter, this is another filter. So one filter will be in the action, another filter will be under flushing part. So one will be kept for flushing, then this will be operational. So that kind of a thing it is there. You are seeing here, this is a the series of filters have been put up. So one filter will work, the another filter will be stopped, and that will be in the flushing mode. So bypass mode or flushing mode. So normally when we are designing the filter or deciding the size of the filtration unit, what happened? We take into consideration that what is the filter's opening. I'm talking about the screen filter. Okay, so the size of the whatever size of the or emitter size, suppose it is a the diameter of the emitter outlet is, let us say it is a 1.5 millimeter. 1.5 millimeter is the diameter. Then the filter opening means your screens or strainers, it should be 1/7 to 1/10 size. That is of the size of the emitter orifice. Okay, so that is how it is decided, and normally these screen filters or strainer filters, they vary from 80 mesh to 200 mesh. 80 mesh to 200 mesh. What is a mesh? Suppose if I say 80 mesh, any one of you can tell what is 80 mesh, meaning of the 80 mesh? Eighty mesh means, suppose it is a you are taking a a wire mesh, that is your stainless steel, the strainer, it is there. So there will be 80 number of wires per inch, per square inch. So 1 inch by 1 inch, you will find there are 80 number of wires. Okay, so if it is a say 200 mesh means the number of wires are 200 in number in 1 inch by 1 inch square, the screen size. So more the number of wires, more the number of mesh means lesser the size of the hole. So 80 mesh has got 175 micron size opening, and 200 mesh means it has got the 74 micron. That is the opening. I am not going to read this part, but I have already told you physical, chemical, biological, these are the major potential cause for the clogging of the zipper. I will not read all these parts. So there are different types of filters which are used. So one of these filter is a gravity filter. Settling basin, just now I told you, is the one of the category. It falls under the category of gravity filter. Screen filter is the another kind of a filter where wire mesh, which is made up of stainless steel, or it is made up of a high quality plastic. So a screen is used, or it is a disc filter. On the disc also very fine smaller holes are provided, openings are provided, or it is a sand filter, or it can be centrifugal filter. So these are the different types of filter which are used. This is what you are seeing here. This is a sand filter, media filter, or gravel filter, and these could be horizontal or vertical. Horizontal or vertical. I will show you the diagram. So both are working perfectly. I cannot say that this is better than the other one. Both are working nicely, horizontal as well as vertical, depending on the availability. One has to take care, and but only thing that how you are packing the filter, how you are grading the material, that itself is a important criteria. And then design of the filter, it comes under the design of filter, but in the today's lab class I'm not going to discuss that part. So this is a screen filter. What you are seeing in this cylinder opening, you are seeing the larger size on which the this cylinder, the wireless is wrapped. It is wrapped over the, it is a put up over the cylinder. Then you are seeing here disc filter. This is a centrifugal filter. Already I have told you in the beginning. You can see when you are disassembling a screen filter, it is like this. So water is coming from this end, and then if you are seeing from the top, you are opening out. Opening means you are taking out this with the help of cylinder. So this is one on the top, that disc is there, and on which the rubber gasket is provided, so that when the water is flowing, it will not allow the water to come out. And then there are two cylinders. So water is coming from this one, from this end, from the pump, or from the screen, your gravel filter. It comes and then it goes to the this cylinder. So size of the mesh, it is larger as compared to the inner cylinder, and then this mesh will be further, it will go. So whether you can say in here it could be, as I told you, the 80 mesh, and then inside it could be 200 mesh, like this. So these are the things which are there. Disc filter, then sand filter. You are, this particular diagram which you are seeing, where the material is put up here. So this is a normal, commonly mode that water is coming from the filter, and then it goes to the system. This is the hydrocyclone filter. I was telling you the water enters here, and then it makes circular path, and that the particles, it get deposited here. So solid particles are purged based on the system, make up the water to clean, and then cleaner water, relatively cleaner water, it goes to the system. So these are the different types of filters. Let me just see. I will not read all this part. No, I don't think it is needed at this stage. Okay, so this is the part. Let me show you the other part. So a gravel filter I am just showing you, which we have in the lab, because you people are not coming to the lab physical mode. You don't want to see. That is a problem with you people. So just you see the diagram what I am showing you here. This is the cylinder. This is a vertical gravel filter. So there are how I was telling you that the gravel and sand is packed inside the filter. So layer 1 has got the 25 millimeter size pebble. Okay, and then on the top you are seeing there is a 12 millimeter quartz. Okay, so that is the size, and then further the smaller size of quartz, it is a smaller medium, rather you can say, size sand is filled on this one, and then further 1.5 millimeter. So like this is a packed here water which is supplied from this end. There is a water supply, so it comes here, and then what will happen, the water will be come into this is a funnel kind of a thing what you are seeing. This is a conical shape funnel. So when water is coming, and the water will be oozing out, it goes to the layers, and finally it will enter from this end, and then it will allow the water to go to the strainer filter, or it may be supplied to the main pipeline, directly to the main pipeline. Now when we need to flush the filter, so this is the it is the this is the working part, and this is the backwashing part. So when we are doing the filter is in operation, means it is working. So this valve is closed and this valve is opened, and then water, it is what you are seeing, this it is going to the layer of the bed, and then it enters from this end, and then what happened, a clean water, it will go to the drip system. It is going to the drip irrigation system. Now what happened when we are supplying water, and then if there is a lot of dirt along with the smaller particles, when it is flowing along with the water, so it is likely that the filter it has been clogged or it is getting clogged. So we need to flush the filter. So flushing of filter is known as a backwashing. Now in case of backwashing, what happened? This valve is closed. Okay, this valve is closed. Earlier this valve was open, and then water is supplied from this end. So when water is being supplied from this end, what happened? It is entering, and water will be coming out of this, and then water will be going like this, and it will enter into this funnel. So the dirt deposited in the filter material in the gravel on the and the means the spaces between the gravel and the fine or coarse sand, that flush, it will be washed, and then finally the dirt particles will be removed by this. So this is a backwashing mode. This is a filtration mode. This is the backwashing mode of the filter. Okay. So this way the backwashing in case of the gravel filter, it is a performed. Now when we are doing experiment, what we are doing, we want to find out the filtration efficiency of any filter. So what we do, we install the filter in the field, and then we start the pump, and also we monitor the pressure, that at what pressure the system is in operation. So that pressure is given, and then when we find that the system is equilibrium, means discharge is not varying with the pressure, means at a given pressure it is almost equilibrium discharge has reached, then what happened? We collect the water sample at the inlet end of the filter and also at the outlet end of the filter, and then this water, what we are doing, we are putting in a passing through a blotting paper. Now, so first we weigh the blotting paper, what is the weight of the blotting paper, and then what we do, we are the taking the we are means collecting the sample. We are collecting this, whatever the sand or whatever it is passed, it has passed through this one. So we will be weighing the blotting paper with the water, and then what we can do, yeah, this particular blotting paper where we have passed the water from this blotting paper, we put it in the oven for some time. Once it is dried, then we find out the weight. So initial weight and amount of the water which has been collected. This is the thing we are finding out the filtration efficiency. So filtration efficiency is estimated by using the formula Fe equal to 1 minus S naught Se over Si into 100. So filtration efficiency, it is estimated, that is a concentration of the suspension at the filter outlet and the concentration of the filter at the inlet end. So this this ratio 1 minus this ratio will give us that how much amount of water which has been the filter it has really filtered out. So this is a important part which is required, whether it is a any type of filter. We will be collecting sample of the outlet water, we will be collecting sample of inlet water, and then we will filter it and through the blotting paper, and then allow the blotting paper to dry, and finally we will work out the filtration efficiency. And then we can also plot a graph between the sediment concentration versus pressure, and then we can analyze that at different pressure how does the this particular screening means how does the uh, amount of concentration sediment concentration it is varying with the pressure, and then what is the filtration efficiency. So this part is about the filter part. Okay, now let us come to the other part. Let me see. Yeah. So once again, I am repeating here different components of drip system. Uh, the we can divide the drip irrigation system into two parts. Okay, so first part is a control head, then another one is a distribution network. Means we can divide into two parts. One is the control head, another one is distribution network. A control head, it includes a pump or overhead tank, fertilizer or chemical application devices, as well as it can be R and filter. Okay, so control head includes pump or overhead tank, fertigation or chemigation unit, and filters. Okay, now the control head, it has a source of water, means the control head, it is not, rather source of water is not the part of the source of water, rather means it is not the part of the control head, but naturally based on the source of water the pump or overhead tank is installed. A pump, basically it creates the adequate pressure. That is what we say here, that pressurized irrigation system. So adequate pressure head is created by a pump, and these pumps can be a centrifugal pump, it can be submersible pump. That will depend upon the amount of water, amount of pressure, and at what depth water we are pumping, taking out water. So we will decide a particular type of a pump. The important thing is we need to develop adequate pressure in the pipeline so that the water can be applied at all the points of the field. Okay, if it is say your pump is or source of water is located at the foothill, okay, it is available at the foothill, and then your area plantation is on the hilly terrain. So, and hilly terrain, the last point is at a very high elevation, and so pump which is there at the foothill of the foothill, and then my pump should be able to create adequate head so that at the top point the water can reach there, and then drip system or micro sprinkler, it can be operated. That is another part. Now then there was a particular term which is known as a bypass line, a line that is provided so that the pump water can be used for other activities when irrigation is not going on. This kind of a system is also needed, or we want to divert part of the water for other purpose. A fertilizer applicator to aid fertilizer or chemical along with the water, irrigation water. So fertigation unit is important. Pressure gauge, it is required to measure the pressure in the pipeline. Sand filter to remove the coarse or impurities in the water which is coming from the source, which is likely to clog the system. Gate valve to regulate the flow of water in the main pipeline, and screen filter. A line filter is placed at the end of the control head to avoid clogging in the drippers. Okay, so this is a screen filter, fan filter, cytocyclone filter. Those are all the part of the control head. Now, distribution network is the another important component in drip irrigation system, which we call it as this part is responsible for distributing the water at different points in the field wherever the plantation is there, and by control head. Then a distribution network consists of the main pipeline, it consists of the sub-main pipeline, it consists of the lateral pipeline. Okay, so main pipeline, as I told you, it is made up of HDPE, PVC. It could be in the size from 2" to 3" or 4". It could be, any size. That will depend upon, as I told you, that how many number of plants, number of trees, area you are irrigating, how much area you are irrigating. So accordingly, the size of the pump, size of the pipe is decided. And then this should, when we are deciding a size, that particular pipeline should withstand the pressure. So this is recommended that about 4 to 6 kg per square centimeter it can withstand. So it is a testing is being done. When you are laying say main pipeline and then suddenly you are required to take your tractor from that area, and whether this pipeline is likely to get cracked or it will be there, so it should be withstand the tractor load. This type of thing it is always tested. Some main pipeline, same thing, that it is normally made up of the HDP or PVC. It's not PVD. It is a PVC. This is a PVC. Okay. It is in the range of 37 to 63 millimeter in diameter, and it can withstand the pressure rating of 2 to 5 kg per square centimeter. That is the pressure rating. It should withstand this much of pressure. Ball valve to engage or disengage a specific sub-main. Okay, I was telling you, for example, I was giving you that suppose there are 10,000 plants. Okay, now these 10,000 means plants are given in a 5-hectare area. Now what you are deciding that the total 10,000 plants are to be irrigated in 4 zones. What you have given, you have divided this total area in 4 zones. So in zone 1 there are 2,500 plants, and then this 2,500 plants will be receiving water from the one particular sub-main. So this sub-main will be operated by the opening and closing will be done by the valve, and this valve could be a ball valve. Okay, flush valve, this is provided at the end of the sub-main pipeline. This is provided at the end of the your lateral pipeline. So this will depend upon that. So these are provided at the end of sub-main pipeline and used to flush. Laterals are made up of LDPE or LLDPE. These are available in variety of sizes: 10 millimeter, 12 millimeter, 16 millimeter, 20 millimeter in diameter, and this should be able to withstand the pressure of 2 kg per square centimeter. That much pressure, the pressure when pipe is coming, it should not burst out. Okay, so the drippers are attached with the lateral pipeline. These are the smaller emission devices that has got small flow rates and are made up of polypropylene. These individual drippers these individual drippers are provided exactly at a specific place where irrigation is desired. It may be required that one dripper is needed for one plant, one dripper is needed for 4 plants, or 4 drippers are needed for one plant. That will depend upon the water requirement of the plant and size of the dripper. I don't want to read all these things, but yeah, that is the main thing, that why we are interested to use drip irrigation system. Our aim is to increase the yield, our aim is to save the water, our aim is to improve the quality of produce, our aim is to save the fertilizer. So these are the some of the advantage. And then the total duration of the crop, it is more, we are getting early maturity, we are getting better quality of produce, because you are maintaining desired amount of moisture at the root zone of the plant, you are controlling the fertilizer. So all the your, and then another advantage is IoT based system. Now the internet connectivity, all that, the when we are talking about artificial intelligence and all that, this is possible to very much use in the pressurized irrigation system. Early maturity of the crop or fruits, control of weeds, use water to a certain extent, and labor, means saving in the labor. This particular irrigation system, it can be used for variety of crops like row crops, sugar cane, vegetable, flowers, cotton, strawberry. Nowadays, this uh, paddy as well as wheat, we have tested that drip irrigation system, it is working satisfactorily for these crops. Only that thing that it is expensive. So Government of India is promoting micro irrigation system to the tune of 50%. The Government of India, it gives support, and state governments are also supporting. It is means it can be used for the row crops, it can be used for the orchard crops like grapes, banana, betel wine, mulberry, citrus, mango, variety of crops, plantation crops, forest plantation, all these things you may find that it is being done. Now let us see the experimental setup for which the data are provided to you. So what you are seeing here, that we have an experimental setup, and where there is a test bench, and on this test bench the drippers are being mounted, and then water is being collected when you are operating at a given pressure. So you need to have the desired pressure. Suppose you are operating it at pressure 1, that is your 1 kg per square centimeter, 0.5 kg per square centimeter, 0.75 kg. So different pressure you are operating, and then you are collecting the water in a given time. So you will get, this is the discharge of a dripper. So normally these drippers are available in 2 liter per hour, 4 liter per hour, 6 liter per hour, 8 liter per hour, like this. Now when we are collecting this amount of water, means when the system it gets stabilized, and we keep collecting water, and then what we are doing, we are taking repeated trial. So any variation in the values, that is averaged out, and then average value is used. Suppose you have operated for 1 kg per square centimeter, there are 3 observations you have taken, or 4 observations you have taken. So those 4 observations you are taking the measuring the discharge, and that discharge at point here, this point, and all that. So those data are used for calculating the various parameters. So one of the parameter for evaluation is manufacturing characteristics. So as per the, now this is your old ASAE, and now it has become ASABE. What is that? American Society of Agricultural and Biological Engineers. Same thing, our BIS has also recommended more or less same table. It has been recommended. Now you are collecting with the help of a test bench, and you want to find out the one of the parameter is manufacturing characteristics. manufacturing characteristics is estimated by finding out the coefficient of variation, by determining the coefficient of variation of drippers. Suppose you have taken data from 10 drippers. Okay, now these 10 drippers, from those data you are finding out what is the standard deviation in their discharge values and what is the average discharge. So this standard deviation by the average flow rate will give the coefficient of variation. Now this coefficient of variation, when you are comparing or using this table to find out what is the under which category these drippers are there. So these drippers, when manufacturing is being taken place, we are taking randomly selecting from the lot. We keep after the 1 hour of manufacturing, we collect the sample and find out from that sample 25 number of drippers are taken and they are put up under the test bench, and then we are collecting observation and finding out the coefficient of variation. Now if CV is less than 0.05, we say for a point source dripper type of dripper, if it is less than 0.05, we say it is under excellent category. When it is within the 0.05 to 0.07, it is the average category. And if CV it exceeds greater than 0.15, the entire lot of the drippers is rejected. It is not accepted. So that is the way manufacturing coefficient of variation is determined, and the dripper should be used or it should not be used. For otherwise, basic someone is spending lakhs of rupees and then he doesn't find that it is not working satisfactorily, the basic aim of the drip irrigation system will be lost. So this is one category, point source dripper, and this is all inline line source dripper. Line source dripper is nothing but inline type of dripper. Means it is similar to, like rather we say, in the drip system itself, the pipeline. Further, the holes are made by laser technique, and then water being taken out. Or inline type of dripper is also, it falls under the line source dripper. Or not all inline will be the line source. That is a bivalve, turbo tape. Those type of drippers are used as a line source of dripper. So if you are interested, please come to the department. I will show you those line source, and then today of course I am going to show you the one video, so that video perhaps it will make you to understand. Then another characteristics is hydraulic characteristics. Hydraulic characteristics of dripper means it is evaluated by characterizing it. The Q is a function of the operating pressure, and which can be given by Q equal to KD s to the power x. So we find out the value of KD, means you are operating these drippers which we have taken in the random slot, and then you are operating at the different pressure, and then you find out what is the KD and what is the X value. So based on the KD the coefficient of discharge, based on the value of exponent, the emitters are classified. If X equal to 0, means X equal to from 0 to 0.3, it is brought under the pressure compensating dripper. What does it mean? That irrespective of whatever you are changing the value of H, discharge variation is in very limited range, particularly for pressure compensating dripper. In case of if X equal to 0.4, we call it as it is a vortex type of dripper, and if X equal to 0.5, we call it as a turbulent flow dripper, or it is a orifice type of dripper. This is nothing but your orifice formula, when Q equal to K, coefficient of discharge, and H to the power half. That is your nothing but s to the power means your square root of h. This becomes your Q equal to KD into square root of h, which is nothing but the your Fish Pro formula. Now, if your x is between 0.6 to 0.8, it is mostly turbulent. We put up under the category of long path spiral type of or long or spiral path drip emitter. And if x equal to 0.9, we say it is a microtube, it is a following, or if x equal to 1, means it is a laminar flow. So there is a not minimum, means there is no resistance to the flow. The flow it becomes in laminar, then there is a smooth flow it is taking place, and that is a in case of microtube. If in place of dripper, instead of putting those drippers, if you are putting a microtube, that microtube will be behaving like a capillary tube. Very important third characteristic is operational characteristics. Under operational characteristics, there are different evaluation parameters. So one is your emission uniformity, another is your absolute uniformity, and third parameter is percentage difference. Percentage difference. Once again, I am reading. The operational characteristics is characterized by the uniformity of water distribution by drippers. So if you are taking the data from the field and making observation, okay. Now if I say I want to find out the emission uniformity. So you have taken 25 number of the samples from the drippers data of the discharges you have collected. Now from those, rather 25, I say 24, let us say. So there are 24 number of observation of the discharges data from the drippers you have collected, and these from 24, what you are finding out, the average discharge. So there are 24 number of discharges, that is Q1 to Q24. Okay. So your QA is nothing but Q1 plus Q2 plus Q3 plus Q24, like this, divided by number of observations, that is a 24. This will give you QA. Now Qn is the 1/4 of the lowest 1/4. Now these 24 number of observations, what you are doing, you are arranging these data in descending order of the magnitude. Okay. Now, so first from there, when descending order you are putting, so 1/4, it becomes 6 number of observations. So those 6 values, what you are doing, those 6 values are used in calculation of the emission uniformity. So what you are doing, from the average of 6 discharges, these 6 discharges are in the descending order, that is a minimum value. Those lowest 1/4 value, that 6 discharge, we will be taking average of 6, that is divided by average of 24, and then that has to be used for finding out the emission uniformity. Then absolute emission uniformity is another parameter which you have to find out, that is given by half of Qn divided by Qa plus Qa divided by Qx. So Qa, same thing what I have told you, that is a average of 24 number of observation, and Qn is the nominal flow rate. What is this nominal flow rate? That is the flow rate. Suppose drippers are 4 liter per hour. So, but it is giving some other value. So this Qn will be used as a 4 liter divided by average of 24 values plus average of 24 number of drippers divided by Qx. Now Qx is the highest 1/3, 1/8. highest 1/8. I have told you that we have taken 24 number of data. Now this time what we are doing, we are arranging our these dripper discharges in the descending order of the magnitude. Okay, so in descending order of the magnitude, when you are picking the top 3 values, you will be taking 1/8 is nothing but 3 values. So top 3 values, their average you are using it, and that average value will be used as a QX. Okay, so 1/3 of that value will be used. Now you are finding out the percentage difference. So QR, that is the nominal flow rate. That is, this should be actually Qn, not the QR. This should be Qn minus Qa divided by Qn. Okay, so this way you will be finding out the percentage difference. Now these data are to be obtained, and then you are plotting the graph that how does the flow data, flow rate versus the discharge, pressure head, how it is working. So one can plot the data on log sheet and find out the relationship of the KD and X. One can find out what is the value of your CV, that is the coefficient of variation. One can find out the emission uniformity. One can find out the absolute uniformity. So all these 3 data are to be obtained. Okay, hope I have cleared. If there is any question on this part, please ask me. Once again, I am telling, when we are evaluating the drip emitters, we are required to evaluate 3 important characteristics. One is manufacturing characteristics, another one is hydraulic characteristics, third one is operational characteristics. All these 3 characteristics one has to evaluate. Then based on these observations, you can categorize the drippers, whether we should accept these drippers, under which category it falls, which are the, whether it is a pressure compensating type, whether it is a vortex type, it is a micro tube type, that we can categorize. That is one part. And also you can find out what is the coefficient of discharge. You can also find out whether emission uniformity, it is within the acceptable range. So in case of a drip irrigation system, emission uniformity, it should be above 90%. In case of drip irrigation system, it should be above 90%. In case of sprinkler irrigation system, you found out coefficient of uniformity. You worked out coefficient of uniformity. Here that is a Christensen coefficient of uniformity. There we were using different formula. There we were doing Cu equal to 1 minus the deviation, individual values, whatever individual values were there. So all the and then multiplied by the average value multiplied by the number of observations, and then divided by the m into n multiplied by 100. That was the formula you use for coefficient of uniformity. That formula we are not using in case of drip irrigation system. That formula is applicable for sprinkler irrigation system. This system is more sensitive to the discharge. It is more sensitive to the pressure. So this is used for evaluating a drip system. Okay. So please let me know any doubt you have, because I have a data which I will share you that file. Let me see that particular data. I can also show you those data, but till this point, any confusion, any query you have? Any one of you? After this, data I am sharing you, and your this video clip will be run. There are two video clips. One is for the lab part, another one is in the field evaluation, and then uh, we will have the your discussion. Not only discussion, we will have your evaluation, that what you have learned in last these two classes. Okay, so if you have any query right now, you can ask. Okay, you don't have, so let me share you the data. Just a minute. Okay, let me find out the file. So here that these are the values which are given here. There are 10 number of drippers. These are 10 number of drippers. From these 10 number of drippers, the data were collected in a beaker having, so the data are the volume of water collected from the test bench. So there are three observations. So each individual observation for a particular dripper, you need to take the average of this. Okay, similarly for dripper 2, similarly for dripper 3. So there are 10 is number of here, n is 10. So find out the your all the things which I have told you, coefficient of variation. You find out the KD value. Sorry, you find out the KD value and the your x value. So this is for means pressure head of 0.5 kg per square centimeter. Then this is for pressure 0.7. Here only two observations have been taken. No problem. You take the average for a particular dripper. Then this is at 1 kg per square centimeter. These observations are given. So you have been given 0.5, 0.7 and 1. So for these pressures, you plot because this is for 1 minute. So you find out in liter per hour because ml is given. So 80 ml, let us say I'm just putting, let us say 80 ml is the average value for this one. I am not taking average of this, but let us say 80 is the, so this is in 1 minute. So in 60 minute, how much? So that will be the discharge of a dripper of means a dripper 1 at a 0.5 kg per square centimeter. So like this, you will be having, you have been given all these data for different discharges. To find out the relationship between Q versus H, operating pressure. Then you find out the emission uniformity. You find out the absolute uniformity. You find out the coefficient of variation. You find out the percentage discharge. All right. Any doubt on the data part? Okay. If there is no doubt, now I will ask Mr. Bhadoria is there. Let him run the video clip. So first lab part and then field part.
Uday? Uday? Uday is also out.
I have actually shared because what happened, When I was running, it is to be loaded. I told him that you put it in the YouTube, then give a link, and then it operates, and then otherwise sound doesn't come.
Yes.
That was a problem.
Uday, can you hear us?
दूसरा कौन है इसमें?
Rajesh Ranjan.
वो भी
Yes, sir.
Rajesh, can you run the video?
Actually, I have not got the link, but I'm trying to connect with them.
तो उदय की प्रॉब्लम है सर, उसका फोन है. ओके. यस. Can you share it video students को? Can you not? Sir, Uday has submitted the link to everybody. Send the link to everybody.
Okay. Okay. So वो तो मैं भी कर.
Yes, sir. Am I audible, sir?
Yeah, now you are audible.
Yes, sir. I shared the link, sir, in chat for students. So, students, can you see the link?
Yes,
Can I-
sir. It
Yes.
opened. Yes, sir.
नहीं, इसको उदय, इसको क्यों नहीं, आप नहीं शेयर कर सकते हो?
Yes, sir.
मैं बोल रहा हूँ कि ये तो शेयर किया जा सकता है ना लिंक को?
यहाँ पे नहीं शेयर कर सकते.
क्यों नहीं? हमने तो किया था लास्ट टाइम.
रुके मैं देखता हूँ.
क्या कहाँ पर दिख रहा है वो?
ये आ रहा है. Can you
हाँ?
see? Can you see my shared screen?
Yes, sir.
Okay. Can you hear it?
No, sir. It is not. The
Can you
sound.
hear it?
No, sir. We cannot hear it.
You cannot hear? Uday?
No, sir. I cannot hear also.
ये voice along with sound कैसे जाएगा? That is the problem. Share with sound है क्या इसमें option? Include the computer sound. Now you can hear. Can
I
you hear
have
the
given
sound
you
now?
a rough description
Yes, sir.
about micro irrigation system,
Uday, can
and
you
in the laboratory class
sound as well?
I will be
Yes, sir. I
demonstrating
can
you
hear
Okay.
also.
the
Now it
different
is-
components which are used in micro irrigation system. Of course, in this particular board, certain components have been depicted as well as it is attached. One can see that water which is pumped from the source. So in this particular board which we see, water is being taken from a well and lifted by a pump. This pump can be driven by electric motor or by a diesel engine, or it can be solar operated, solar pump operated pump also it can be done. And then the water is taken from the delivery end of the pipeline in this pipeline, you find that there is one component which is used for injecting fertilizer or any other chemical along with irrigation water. Then it goes to the filter. This is a sand filter, and then water is taken. This is the inlet end of the filter. After it passes through the layer of the sand, and then the water comes out at this point, and then again, depending on the quality of water, then another filter that is known as a screen filter or strainer filter, and then from the strainer filter water is taken to the main pipeline. It goes to the sub-main pipeline. You can see here, this is the attachment where water will be. This is a ball valve which will be supplying water to the sub-main pipeline, and in this sub-main pipeline you can see this is the attachment which we call it as a Grommet Takeoff. So water, this particular pipeline is known as a lateral, which is attached. So here the laterals are of different types. You can see here this lateral is this could be of 12 millimeter, 16 millimeter, 20 millimeter in size, and the material of this particular lateral, it could be linear low density polyethylene or LDP, linear this low density polyethylene. So you can see here the one can attach a drain wall to drain out the water, or one can attach when we want to extend the line. So by taking this one can take the extend the line if someone wants to take it. So, and this part you see that inside the pipeline, lateral pipeline, this is the opening it has been provided. This is the inline type of drip emitter that is your inside the pipeline itself, and normally such pipelines are buried below the ground level, below the land surface, and water is supplied exactly at the root zone depth. This is another very the material, this is the strength of this one is less, and this is a thin pipe in which the drippers, you can see here, the drip system is attached in the pipeline and water is coming from these outlets provided. So this is a one kind of a thing. And then another interesting part, that one can reduce the pipeline. Say this is a 16 millimeter pipeline, and one can reduce the pipeline. One can attach you can see here 12 millimeter, 16 millimeter, 12 millimeter. This can be the pipeline of one particular size, and then another pipeline, one reducer one can put. So when we want to extend the length of the pipeline, so at the lower end discharge decreases. So instead of taking the larger size lateral pipeline, one can reduce the diameter of pipeline. And depending on the requirement, one can take water in different directions. If there are some certain places where irrigation is to be given, so one can take it. Now there are several components which are there, which are now it is available, which is made up of plastic. So you can see here PVC T is there available, and this is one kind. This is one filter which you see that this is a one filter, and this you are seeing that this is a sprinkler system. So what I was telling you, that in the drip lateral system, the drippers are attached. These drippers can be this kind of a thing where one can see that this part here. Say this is a this is known as a barb, which will go inside the pipeline, and if you open, this is the one part, and this part is a upper part, and inside the drip system, this particular tablet. This tablet is a energy dissipator. This is a energy dissipator. So water enters from this end, it comes to this end, and then here you can see the this is a labyrinth path. So water goes through this labyrinth path, which is working like energy dissipator. So water which comes in a pressure, pressure gets reduced, and then it comes out in the form of a small. It comes out in the form of a droplets, and then finally it emerges out of this. So a typical dripper, it is, you can see a online type of dripper which is available commercially. Here this involves three components, whereas a we have at IIT Kharagpur, we have a developed dripper where we have reduced from three components to two components, and the important feature of this particular dripper that you can regulate the flow. It is a regulating, means one can regulate the flow, so one can close the completely the flow rate, or one can regulate the flow from low value to a very high value. So you can see here these two components, when we are keeping it out, this is like that. So this is a fully open. Now if I start closing it, so the opening is start reducing, and then slowly you will find that. So from this dripper I can get discharge from 0 liter per hour to, means 0 for no flow, to as high as more than 50 to 60 liter per hour that we have monitored. So if the plant is of high water requirement, such type of dripper it can be used, and moreover we are reducing the total plastic involvement when we have to give water to the lakhs of plant. So number of drippers when it is in, so plastic requirement and the cost of the drippers can be reduced. The another kind of a device which we call it as a inline type of inline kind of a device. Now inline type of device, you can see this is in this particular component inline device is inserted into pipeline, and this place you are seeing a hole. This hole basically is the outlet, so water enters. Now the device is something, the inside part it looks like this, which is inserted in the pipeline. Of course this is of a little larger diameter, this is a smaller diameter pipeline. So this is a 16 millimeter diameter pipeline which is inserted at the time of manufacturing, and you can see here the water will enter from one end, and then it goes in this zigzag path, and finally it will come out. So it will come out from this particular hole. So these, whether it is an online type of dripper or it is an inline type of dripper, these are available in different discharges. And in today's in the lab class, our aim is to evaluate the performance of online type of dripper. So we will carry out research the relationship between discharge. So there are different kinds of a dripper. You have seen that this is a turbo key, this is turbo partially your compensating type of dripper. This is a non-pressure compensating. Now when suppose we do not need water at a particular place, so there is a provision one can close. It is a similar to that what I have told you, that yeah, one can close. This is a inline kind of a dripper. Online means it is inline type of dripper, but the total labyrinth path is reduced in this case. This is again, the water comes from the zigzag path, inline kind of a dripper only, and then water will come out drop by drop. These are the, one has to cut the pipeline, and then conceptually similar kind of thing it has been made. This has to be inserted at the time of manufacturing. Here pipe has to be cut and then joined. The lateral pipe has to be joined from both the ends. So that will become your J inline kind of a dripper. Now there are other devices which are used. So one of the device, when we want to get water drop by drop, very fine mist we want to make it. So, and particularly for increasing the humidity, means the water droplets are not falling on the soil surface, but it will remain in the means the greenhouse in the surface. So it will increase the relative humidity of the air, and then water level will create the lower temperature. Now if the quality of water is poor, and then water can be given by using a drip bubbler. The discharge from a bubbler is relatively very large. It is directly fitted with the pipeline, and this part is threaded part, and then one can get it. If I want to create a small jet, and for half 180 degree or 360 degree, so these kind of jets are also available, and these are micro sprinkler is the device which I was telling you that micro sprinkler is the device. This is when the water is coming from this end, so it is fitted over this part. This particular part will go into this one, and then water will come from this end, and then this will push the water, so this will start spinning. This will start spinning means it will be spinning the water all throughout, and so when the water jet it comes, it strikes these two arms, so it finally it covers, it forms a droplets, and then when we want to give irrigation for close growing crop, micro sprinklers are used. And some cases, in some time, we need to see the quality of water is poor. At that particular point also, the micro sprinklers are used. Microjet, it is another form of the micro sprinkler. The jet will appear, it will strike here, and then break into this thing. We want to flush the lateral pipeline instead of opening the lateral pipeline. So such type of provision is there. When you are closing the pipe, irrigation water supply, water will be flushed out of this thing. So there are different components. Now when we want to take out or connect a lateral with the sub-main pipeline, these kinds of Grommet Takeoff, HDPE takeoff, it is written here, Grommet Takeoff. So practically this is the part which has gone, so this is the grommet, and then this part is the connection. So this can be connected. Now it's a very interesting thing that at one point of time people were doing, using the metal they were using. So all these things have been replaced with the plastic. So you can see here, this is the HDPE takeoff or LDPE takeoff, Grommet takeoff, means you are connecting with one pipeline with another material pipeline, such type of thing. This is now poly T, that we want to take the water perpendicular to the other direction, you want and then this supply is there, you want to take the pipeline, just closing, instead of closing the pipeline, the same pipeline can be connected and perpendicular. So elbow is available, Poly joiner when we want to extend the length of the pipeline. So one lateral with the other lateral of the same size, it can be connected. These are available in 12 millimeter, 16 millimeter, 20 millimeter in size. Reducers is also available. Just now when I was showing you the previous case, so if it is a pipeline is of 16 millimeter, I want to connect the 12 millimeter pipeline. That can, such provision is there. Goop plug, certain emitters you want to, it is not operational, you don't want to give irrigation to this thing. So one can plug the hole by using the goop plug. In order to terminate the lateral pipeline, O shape or this 8 shape, such type of things, this is there. So pipeline is coming like this. You can bend the pipeline and you can make it like this. You can see here how the pipeline it goes. So you can, what you are doing it, you are closing it and connecting this pipeline with this one. So this becomes, you are here, you can see here. So you are terminating the pipeline. So at the end, when this is the end of the length of the lateral. So if I have to flush the water, then we have to remove, and this is only possible when we want to reduce the cost of the flushing lateral. If I want to have a sophisticated system, then lateral can be flushed. This is the another arrangement. You can see the one can attach drip lateral with the tape. So one pipe is made up of LDP, another one is LLDP, and then tape has got inline kind of thing. So such provision is also there. One can connect with the or with the tape with the poly joiner, means you have a tape pipeline. So tape pipeline can be connected with the lateral pipeline. So such kind of a thing, it is possible to connect. And this is an inline filter. Now in the earlier case I was showing you that in a drip system, fertilizer or any other chemical herbicide or even the pesticides, that can be injected along with the irrigation water. And so injection can be done by using a constant head tank, or it can be done by using the Venturi system, or by using a injection pump. Such provision is there in the drip irrigation system. I can here show you, and you will be also conducting a separate lab class on this. So you can see this component, this part of the Venturi system, Venturi injector system. This is the part which will go in the tank, and then this component, what you are doing, the water is being supplied, from one end, and then there is a pressure reducing valve. There will be two pressure reducing valve. So pressure will be when you are putting it, and then the main important part is this one, that you have now these two ends. So one end is your inlet end, another one is outlet end, and this is the part where the diameter of the pipeline has been reduced. So area of flow is reduced. That is causing the change in the velocity, and thereby it is creating the negative pressure, and with the suction, the fertilizer which is kept in the tank, it is being injected with the system. You will in order to calibrate the Venturi system at what pressure it should be operated, that can be always can be done separately. But as far as the part is concerned, so this is one way of injecting fertilizer in the drip irrigation system.
This is a hydraulic test bench for evaluation of drip emitters. This hydraulic test bench is meant for finding out the emission uniformity of drip emitters. So, a pump is used to collect water from the source, then water comes through a set of drip irrigation filters, then it goes to the main pipeline. From main pipeline it goes to the submain and lateral pipeline. In this particular laboratory experiment, we have kept in the lab where you can see the water is taken from the source. So, this is a collection tank which is a sump, and in this sump the water is stored, and then the water is pumped. So, this is the suction end of the pump, this side is the delivery end of the pump, and this pump is coupled with a small motor. Then the water is being pumped, it comes to the this delivery end of the pump, and then it goes to the lateral pipeline. So, in this lateral pipeline, this is a lateral pipeline, we have attached drip emitters. There are 10 number of drip emitters which are spaced at 30 centimeter spacing. We will evaluate the performance of these drip emitters. Now, performance, it means that we want to see how the water is getting distributed, or it is passing when, so amount of water which is getting distributed in all these drippers. So, how uniform this water is being distributed? We will take the observations in a given time of water dispensing out of these emitters. So, water will be collected with the help of these graduated flask, where you can see here each graduated flask is of 250 milliliter. So, for a given time amount of water which is collected in the collecting flask, and then we will find out how much discharge it is coming out of the drippers. So, one part is to find out the uniformity. So, in the theory class we have explained you different types of emission uniformity. What happened when these drippers are being manufactured? There could be some manufacturing defect. So, there we can also find out manufacturing coefficient of variation. So, we will evaluate from the data collected from this. Then this is a very important aspect, that to classify the dripper under which category it passes through. So, we will be evaluating the pressure discharge relationship. So, this test bench has provision where we are using a pressure gauge, that how much pressure is available at the supply end of the lateral, that is at the inlet end of the lateral. Now, in this test bench one can change the slope, means when the laterals are to be laid up the hill, or laterals are coming down the hill. So, in this case up to 10%, means this, if you see here, this slot is made so that we can change the slope. So, when we will bring down, it means the lateral will go up the hill.
so up to 10%. So this particular, it is a of 30 centimeter. This fall is there, fall in the slope, and then the other end also, if you see here, this end also there is a provision. So if I put it on the top and then bring the lateral position at this place, that is 30 centimeter down, so it will be again there will be, so we can have the gradual variation in the slope, which normally it exists in the field that lateral is placed up the slope or down the slope. So effect of the slope on the discharge and pressure relationship, this also varies, and how much is the head available at the drip emitter, accordingly the discharge will be coming out of this. So we are now going to start the test the data which will be collected from these drippers. The operating pressure to supply water in the drip lateral is 1 kg per square centimeter, which is equivalent to 10 meter of water column. We start. Nine ml of water has been collected from the dripper. When we will collect set of these data, from these data we will find out the coefficient of discharge and exponent x.
Sir, any other video we have?
Yes, sir, I'll share.
You said.
Control head unit of drip irrigation is being shown over here. It's taken.
Video is not coming. Yeah, now it is okay. Run it.
Yes, sir.
Yeah, field demonstration.
Control head unit of drip irrigation is being shown over here. Water is taken from the deep tube well. In this deep tube well, a submersible pump is attached over there. So in this submersible pump, this is the delivery end of the pump, then water is being taken into the system. Now the water will come. So this particular unit where the water is being raised by using an elbow. So this is the supply end, and at the supply end you see this place is the pressure gauge. This is the inlet end of the gravel filter, where at inlet end we have attach one pressure gauge, and then in this pressure gauge, in this particular sand filter, sand is of different grades have been filled in. So water passes from this filter, it goes to the layer, and then at the downstream end you can see this is the outlet end of the sand filter. So water passes through the
this particular material, and then filtered water it enters to the system, then it comes to this end. So these two ends, one is the inlet end, pressure gauge is attached, at this, that the pressure head gives that how much is the pressure difference it has caused, whether sand is blocked by the impurities available in the water. Then it comes to the, this is a gate valve where we can regulate the flow, and then this part is having a venturi injector. This venturi injector is for injecting the chemical, nutrient or fertilizer which is soluble in water, is supplied to the system. Then we come to the, this is a screen filter. So water will pass through the screen filter, then it goes to the pipeline, and then here there is a arrangement where one can measure what is the uh, volume of water, what is the volume of water it is passing through the this particular pipeline. So in a given time the volume of water which passes is measured. So here there is a counter, one can see in this counter the there are different uh, the graduation which has been made, where it can be monitored, and then the water goes to the main pipeline. From this place onward the water is supplied to the field, where the network of the sub main pipeline and lateral pipelines are attached. Here I am demonstrating you how to attach lateral with sub main pipeline. So in installation this is one of the important tasks. Main pipeline supplies water to the sub main pipeline. So main pipeline is usually larger in size so as to supply more water, and pipeline could be made up of PVC or HDPE. Now here I am showing you, this is a sub main pipeline which is made up of HDPE. Now in this pipeline, when we want to attach lateral pipeline, so uh, we will make a hole by using the drill bit. Now this is a field operation because this pipeline will be laid below the ground level and in the field. Just to demonstrate you, I am showing you separately to learn about the how the lateral pipeline is attached with the submain pipeline. So in submain pipeline we are using a drill bit. So using this drill bit a hole will be made, and in the hole we will be placing, this is a gasket, we will be placing gasket, and then there is a GTO. GTO is practically it is a grommet takeoff. So grommet takeoff is of different sizes. If I want to attach 16 millimeter pipeline, so 16 millimeter pipeline will be attached with the grommet takeoff. So normally what is to be done? The water which is coming say from this direction. So direction of the grommet takeoff inlet, it will be in this direction, means perpendicular to the direction of the flow where the water will be entering, and then a lateral pipeline will be attached with the grommet takeoff. And on the lateral pipeline we will place dripper at appropriate location. This is a dripper, and dripper will be attached with the help of a punch. So you can see how the hole is being made by using dripper drill bit, and then how the grommet takeoff is being inserted inside the submain pipeline. नीचे रखो as if it is in the ground ना. This is a hole which has been made with the help of a drill bit. Now you can see here, after the hole was made, a washer has been placed in the hole so that water does not leak from this place. Now the grommet takeoff. Grommet takeoff has been placed in the hole by attaching the this particular washer. Then the important part is, if the flow is, so this arrow is basically, it is showing the water will be entering from this end. So this is the inlet end of the pipeline where the water will be entering, and then on this a lateral will be attached. So you can see here a lateral has been attached with the submain pipeline. Now on this lateral, as means wherever the position require, we want to give water in the over the plant root zone. So exactly at that place hole will be made, or thoda bada karo. Hole will be made we have attached the lateral pipeline with submain pipeline, lateral pipeline it has been attached with the submain pipeline, and then the dripper has been attached with the lateral pipeline. So one can see that after attaching the drip emitters, how the water it is emerging out of the drip emitter. So the water which is coming out of the drip emitter, it will depend upon the pressure available in the pipeline, and particularly pressure available at the tip of the nozzle, means at this particular place. This has to be monitored from the inlet end of the lateral. Now you can see here, when the lateral, this particular drippers, when we have attached and when we are supplying water, so the water which is coming out from one end to the other end, it forms the waiting circle. This is the waiting circle it will form. So when we are, one party that observing the amount of water which is delivering out of the drip emitter, but all the drip emitters water cannot be collected. So only few sample places this water is being collected for finding out the uniformity of water discharging out of the drippers. So if we take observation, just visual observation, how the waiting circle it is forming, it has formed. So if it is of uniform in size, all throughout field, if you see, if it is of uniform size, it shows that the drippers have given uniform discharge.
Sir, video is over.
Yeah. Sir?
What I am asking whether students it's clear now, so much of elaborate, or scene it has been given to you. Any query you have?
Students?
It is clear, sir.
Yes, sir.
Yeah. Okay, observations you have for 3 different pressure conditions, 0.5, 0.7 and 1 kg per centimeter square.
This observation I have already uploaded.
Yes.
I have uploaded file to them which they will submit. And how about the previous lab, whether they have submitted?
Rajesh? Uday?
Yes, sir.
Have they submitted? Previous
Yes, sir.
Okay.
Sir,
they
very
have,
few guys submitted, sir.
huh?
Very few persons submitted.
Okay. So you mark the late submission as well, because usually we are giving up to Saturday midnight. Students?
Yes, sir.
We have given you time, sufficient time. So
Any doubt if you have on today's experiment or in previous experiment, the same similar kind of video it was run. Besides video, theory part also it was covered. Okay, I think they don't have query and they don't want to also learn.
that is the main problem. Online problem.
No. What I want to ask them whether they have understood fully. Some of them they have left. I think now it's how many are there actually?
Let me take attendance, sir.
Yeah.
It's just 35 students are present here.
35 are present. Not take attendance right now, and then put them, let there be absent. Why they are doing like this? Let there be absent for them.
Yes. Only 30.
Anyone, I can see here the name, one is Chilpuri is there. Chilupuri.
Yes, sir.
Yeah. Any question do you have?
No, sir.
What did you learn from today's lab? If you have no question, then what did you learn? Okay, I think Mishra ji, let us close the thing.
Okay, sir. Okay, sir. Students, what date could be suitable to you to have a Viva Bosi and one test? Anybody? Lakhwat?
आप उनको डेट दे दीजिए और
Yes, sir. I need to give them. Actually, 7 to 13 or 14. It's examination schedule. That's why I am asking if they want to give. Otherwise, after exam, I will conduct. But okay, I will write an email.
Sir,
Yes.
sir, we will discuss and sir, we
Discuss
can
and give me today or maximum tomorrow. 2 days I need to conduct the Viva boost because 50% students at a time I can cover, and say 1 hour for test. It will be Google form based test. So please suggest me the timing. Otherwise, I will decide tomorrow. Okay.
okay, sir, we'll decide.
Okay. please communicate the time for me. Time to me. Okay. Okay. See you then.
Okay, sir.
Okay, sir.
Thank you.
Okay. See you then. And submit your lab record by Saturday midnight.
Okay, sir.
Rajesh and Uday, please record late submission if somebody is submitting after that, because this is the last lab. Okay, students, see you. ठीक है उदय?
Yes, sir.
Okay. Okay, Rajesh.
Yes, sir.
Okay, see you.
Sir, Ashok sir,